Let's take a look at nth roots and rational exponents. Now this is a radical right here. Looks something similar to that. And you got something underneath. It's radical. Now, some of them may look like this, where you have a number in this little slot right here. That's called your index. Now, this is referred to as the cube root. This one would be the fourth root. That's why they say nth root. Now, if you have just this symbol here and there is no number, by default, your index is equal to 2. This is called a square root. Now we're going to explore in more detail what the index means with examples. But that's our beginning definitions. And let's take a look at our first problem. We want to simplify the cube root of 27. Well, we need to do the prime factorization of the number that's inside the radical. 27 is 3 times 3 times 3. Now our index, this number in the slot here, is 3. What that means is we're looking for a set of 3 of something. Well, here we have 3 3s. So 3 3s are going to come out in front of our radical as a single 3. So again, the index tells us how many we're looking for, and then after you find that many, you bring it out, and it comes out as a single one of them. And that's our answer. This one has a note that goes along with it that I'll talk about after we work the problem. Now our index is 3, which means we're looking for a set of 3 of something. But negative 8 we can rewrite as negative 2 times negative 2 times negative 2. Now, I've been really vague there. I said a set of 3 of something. It doesn't say what it can be. It can be anything. Well, here we have 3 negative 2's. So those 3 negative 2's are going to come out in front as a single negative 2. Now, our note on this says, if you have an odd index and a negative inside the radical, and a negative inside the radical, you can just take the negative out in front. Oops, out in front. So for that example there, I started out with the cube root of negative 8. This says if you have an odd index, which we do, 3, and a negative inside the radical, we do, it's right here, you can just take negative and out in front. So just to begin with, we can just immediately put the negative out in front and not worry about it. That makes it a lot easier in problems. You don't even have to worry about that. Then we work it the same way. We try to come up with something times itself 3 times. Gives you well, the prime factorization of 8. So we got 2 times 2 times 2. Specifically in this section, everything will come out perfectly like I was getting ready to say, but in general, as we get into the other lessons, you'll find that not all the time will the radical disappear. But our index is 3. We're looking for a set of 3 something. Here's 3 2's. So 3 2's is going to come out in front as a single 2. Now the negative is already there, and we just bring out a single 2. So our answer is negative 2. And let's take a look at our next problem. We've got the cube root of 27 over 64. Well, I'm looking for set of 3 of something, and this one's designed to come out nice. 27 is 3 times 3 times 3. And 64 is 4 times 4 times 4. Well, our index is 3. We're looking for a set of 3 of something. Here's 3 3/4. So they're going to come out in front as a single 3/4. And that's our answer. Now the next ones are calculator based, so let me bring up my calculator. Okay, we got the cube root of 73. Well, I'm guessing 73 is prime. I can't think of any way to break that down. So to do that on our calculator, if I can get to the calculator, we're going to press our math button. And we want to choose the cube root, the number 4. So you can down arrow to it, highlight it, and press enter. Or you can just press the number 4 and it'll down arrow and enter for you. And then I'll put in 73 and then enter. And so this is going to equal to 4.2 decimal places, so 4.18. And that's our answer. Next one is a calculator-based one also. So we've got the 4th root of 3, and round it to 2 decimal places again. Well, 3 is prime, so we can't do the prime factorization of it. That's as broke down as it gets. So the only thing we can do is plug in our calculator if we want to take it any further than that. Well, this one's a little bit strange on your calculator. To put this one in, you have to put your index in first. So I'll put 4 in. And then I'll choose math. And then I'm going to choose this 5th one, the one with the radical symbol with an X before it. And if you're got a TA3, TA84, earlier TA84s, you have to put a beginning parentheses. Now the newer TA84s, you don't have to. It puts it in a radical form for you. It's kind of cool how it does it. And then we put 3 in, and then closing parentheses and enter. Now if you go ahead and just put 3 there, it'll work for this problem. But if you have anything more than a single number there, it won't work. So you should get in the habit of whenever you put in like a 4th root, 5th root, 6th root, or whatever, that you always put a beginning parentheses. And this gives us 1.32. And that's our answer. Let me start a new page and we'll look at this next one. Okay, so we got the 4th root of 5 to the 4th. Well, think what 5 to the 4th means. 5 to the 4th means 5 times 5 times 5 times 5. We got 4 5s. Our index is 4, which means we're looking for 4 of something. Well, here's 4 5s, so those 4 5s are going to come out in front as a single 5. And that's our answer. Now, it doesn't work all the time. There's some special cases we'll need to take a look at. But if your index matches the power, then they basically cancel each other out, and you're just left with whatever's inside here, like the 5. So since this was index of 4, this is power of 4, then automatically a new answer is going to be 5. And like I say, there's some special cases we're going to talk about. But let's look at this one. Our index is 3, our power is 3. So again, those basically cancel each other away, and our answer is in. Now this one here. This is one of our special cases. And to understand the answer you get off of this, first off, let's apply what we've been saying. Index is 4, our power is 4. So basically those cancel, and we're left with 5x minus 1. Now, if you remember from elementary algebra, algebra 1, we'd have items like this, square root of 16. And we'd write that as 4 times 4. And since it's a square root, we're looking for a pair of somethings. Here's a pair of 4s, so they come out as a single 4. But we could also have rewrote this. Square root of 16 is equal to negative 4 times negative 4. And remember, with the square root, we're looking for a pair of somethings. Well, here's a pair of negative 4s, so those come out as a negative 4. But in elementary algebra, algebra 1, we learned this was actually our answer. This was not our answer. And there's a note that goes along with this. It says, if your index is even, you can only have positive numbers come out. So if your index is even, you can only have positive numbers come out. That's why our answer here is 4 and not negative 4. Well, how does that deal with this problem? Well, our index is even, which this says that you can only have positive numbers come out. But we have a variable. We actually don't know what this is. If I put in x is equal to 7, for example, 5 times 7 is 35, 35 minus 1 is 34. It's positive, so we're fine. But if I put negative 2 in for the x, 5 times negative 2 is negative 10, minus 1 gives us a negative 11. And we can't have a negative number come out of a radical with an even index. So how we handle that, to make sure it's positive, is we put absolute value bars around it, like that. And that's our answer. Now that only applies to even indexes. Doesn't apply when you have an odd index. So let's look at this next problem. We have negative cube root of 3x minus 5 to the third power. Well, this negative that's out in front, that's out in front. It doesn't change anything. It just stays out in front. Now here our index matches the power, so they're going to cancel each other out. And we're going to be left with 3x minus 5. Now put parentheses around this because the negative that's out in front has to flip the sign of everything. Now I didn't worry about putting absolute value bars around this because this was an odd index. The only time you have to worry about that is when it's an even index. And that negative we can now take through, negative 3x and then plus 5. And that's our answer. Now these next ones are going to demonstrate rational exponents. Now I like to do this by example. It makes more sense. So we got 9 to the 1/2 power. And it says evaluate each expression. Well, this is a rational exponent. Now a lot of people don't remember that term and what it means and so forth. So in class, a lot of times I say fractional power form. It means your exponent is a fraction. Now to simplify this, without using a calculator, we need to put it back in the radical form. Because when you see a fractional power like that, that's a radical. It's just written in a different form. So what we're going to do is we're going to rewrite this in this manner. Now whatever your denominator is up here, this 2, that'll go in this slot where your index, that's your index. Whatever number's up on top, this will be your power. So you can put it right there. Well, whenever our index is 2, we never actually write it, so this is just a square root, and 9 to the first power is 9. Now 9, if I do the prime factorization, is 3 times 3. There is no number in the slot here, it's by default 2, so Our index is 2, so it means we're looking for a pair of somethings, 2 of something. Well, here's 2 3s. So those 2 3s are going to come out in front as a single 3. And that's our answer. This next one has a little note that goes along with it. Some of these are just to refresh your memory on exponents. And you saw this note back in elementary algebra, Algebra 1. It says an exponent only affects what is to its immediate left. So an exponent only affects what's to its immediate left unless there's parentheses, then it affects everything inside of parentheses. And I'm a slow writer. I'm getting there. Okay. An exponent only affects what's to its immediate left unless there's parentheses, and it affects everything inside the parentheses. So this 1/4 power you see here only affects the 256. It doesn't affect the negative. So we're going to write this back in the radical form. So this is going to be 256 to the first power. Again, whatever your denominator is, the 4, that's your index. So that goes right there. And whatever number's up on top here, that's your power. That goes right there. Take my glasses off. They're kind of hurting my ears. There we go. Negative stays out in front, and then we've got the 4th root, and we want to write prime factorization of this. Now, we could do the prime factorization, which is a bunch of 2's, but this is also 4 times 4, which is 16, times another 4, which is 64, times another 4, which is 256. Now, our index is 4, so we're looking for a set of 4 of something. Well, here's 4 4's, so they're going to come out as a single 4. And the negative is already out in front, so our answer would be negative 4. Let me show if you actually did the prime factorization. 256 is 8 2's. It's 2 to the 8th power. 6, 7, 8. So if we did the prime factorization like that, our index is 4, so we're looking for a set of 4 of something. Well, here's 4 2's, so they're going to come out as a single 2. Well, here's another set of 4 2's, so they're also going to come out as a single 2. Try that again. I didn't write that very straight. There we go. So the negative stays out in front. This first set of 2's, these 4 2's, comes out as a single 2. And then this set of 2's, these 4 2's, come out as a single 2. And they come out with multiplication between them. So negative 2 times 2 gives us negative 4. So we'd get the same answer. So it doesn't matter that if you can't see it's 4 times 4 times 4 times 4. If you do the prime factorization, you get the same answer. Let's take a look at this next problem. And it has a note that goes along with it. By themselves, these problems are fairly simple, but there's a lot of little tricks, a lot of notes that goes along with them. Now this one here. If we look at immediately to the left of our exponent, we have parentheses. So this 1/2 affects all of this. So when we put this back in a radical form, it's going to look like this. Again, whatever number's on the bottom in your denominator is your index, and whatever's right here, you put right there. Which we know index of 2 is a square root, so this becomes square root, and the first power drops away. So we've got square root of negative 16. Now our note on this. If your index is even, and you have a negative number, so you have a negative number inside the radical, then the answer is not a real number. We're going to actually see later on in a different lesson, it's actually an imaginary number. So here, if your index is even, here our index is 2, and you have a negative number inside the radical. Well, we have a negative 16 there. Then your answer is not a real number. So our answer here is not a real number. Let's take a look at this problem. This just kind of builds upon what we've already been talking about. We get the fifth root. I should write that a little cleaner. So fifth root of 3y. And it says rewrite each of the following radicals with rational exponent. Well, if I were to put a power inside, this would become 3y to the first power. So, to go backwards, this would become 3y to the 1/5 power. Whatever power is inside here goes up on top. And if you don't have a power like we just have 3y up here, it's by default 1. You don't even have to write that. And then whatever our index is, that goes to our denominator. So 3y to the 1/5 power is our answer. Let's take a look at this one. Number 14. We have the square root of y to the 5th. Well, let me put the index in there. Remember, if you have a square root, it's default 2. And then again, if I were to put a power here, this would be y to the 5th, or y over 5 to the first power. So this becomes y over 5 to the 1/2 power. Again, whatever power is here goes up on top, and whatever your index is goes down in your denominator. So y over 5 to the 1/2 power is our answer. And let me start a new page. This next problem is going to take a few steps written down. So we've got 15, which is 16 to the 5/2 power. And they want us to evaluate each expression. So this is evaluating a number to a fractional power, rational exponent. So to a fractional power where the numerator, the number up on top, is greater than 1. And we got a property that goes along with this particular problem. And I'll write the property down after we work it. The problems are fairly simple, the steps. Property makes it look kind of complex, which usually is the case. Our first step is to put the numerator of the exponent on the outside of a set of parentheses. So this is going to become 16 to the 1/2 power raised to the 5th power. Now notice I took the numerator, which is 5, and put it on the outside of the set of parentheses. Now where the 5 was in the exponent, I put a 1. Step 2. Rewrite what is inside the parentheses in radical form. And simplify. Well, the 16 to the 1/2 power, that becomes the square root of 16. 5th power stays there. Square root of 16. Well, that's 4 times 4. And remember, with the square root, our index is 2, so we're looking for a pair of somethings. Here's a pair of 4s, so a pair of 4s is going to come out in front as a single 4. So we're going to end up with 4, and then the 5th power carries down. Now simplify even, not just the radical, but now you take this to the 5th power. 4 to the 5th power is 1024. And that's our answer. Okay. The property for this is something of this form. And I'll choose, what variable should I choose? Choose m. So if you have m to the a over b power, you can rewrite it as m to the 1 over b power raised to the a power. Or you could rewrite it as m to the a power raised to the 1 over b power. Again, that makes it a lot harder than it needs to be. Let's take a look at another one. Got 8 to the 2/3 power. We got a number to a fractional power where the numerator is greater than 1. Our first step is to again take the number in the numerator of the exponent and put it on the outside of a set of parentheses. So this becomes 8 to the 1/3 raised to the 2nd power. Now next step is to put this back into radical form. So this becomes the cube root of 8. And simplify. Well, if I do the prime factorization of 8, 8 is 2 times 2 times 2. Now our index is 3, so it means we're looking for a set of 3 of something. Well, here's 3 2's. So 3 2's is going to come out in front as a single 2. And then our exponent carries down. So the 2nd power. And 2 squared gives us 4. Let's take a look at number 17. We got 64 to negative 1/2 power. And I always like to show this with an example. This is just refreshing your memory, along with some of the techniques of this section, but it's refreshing your memory on how do you handle negative exponents. Well, remember, if we have a negative exponent, like we got 5 to the negative 2 down in the denominator, what you do is you move it opposite where it's at in a fraction. So I take that 5 to the negative 2, and I take it up on top. Take it to the numerator. And it would become 5 to the positive 2. When you move anything opposite of where it's at in a fraction, the sign of the exponent changes. Now if we start out with something like this, 3 to the negative 2. And in order to move it opposite of where it's at in a fraction, you have to put it into fraction form. So this would become 3 to the negative 2 over 1. And again, we're going to move the part with the negative exponent opposite of where it's at in a fraction. So we'll take 3 to the negative 2 downstairs to the denominator, and it becomes 3 to the positive 2. Well, that's what we're going to do here. We got a negative exponent, and we want to move it opposite where it's at in a fraction. Well, it's not in fraction form, so we want to put it over 1. And now I want to move the part with the negative exponent, the 64 to the negative 1/2, opposite of where it's at in a fraction. So I'll take it downstairs. And it'll become 1 over 64 to the positive 1/2. Now we want to put that back in the radical form. 64 to the 1/2 is the square root of 64. And square root, we're looking for a pair of somethings. 64 we can rewrite as 8 times 8. So our index is 2, it's a square root. So we got a pair of 8, so a pair of 8 is going to come out in front as a single 8. So our answer is 1/8. Let me start a new page. And let's look at this next one. We got 1 over 9 to the, go away, I've asked. 1 over 9 to the negative 3/2. Again, we never want negative exponents. So I'm going to take that 9 to the negative 3/2 and move it to the top. And again, when you move anything opposite where it's at in a fraction, the sign of the exponent changes. So it becomes 9 to the 3/2 over 1. Of course, that 1 can disappear, so we got 9 to the 3/2. Well, now we have a number to a fractional power where our numerator is greater than 1. So we're going to use those 2 steps. We're going to take the number in the numerator, put it on the outside of a set of parentheses. Then we want to rewrite what's inside the parentheses in radical form. So 9 to the 1/2 is the square root of 9, and then the third power carries along. And simplify. Well, 9 is 3 times 3. Our index is 2 because it's a square root, so we're looking for a pair of somethings. So here's a pair of 3's. So a pair of 3's is going to come out in front as a single 3. And then 3 to the third gives us 27. And that's our answer. Okay, on this one we got the 4th root of x to the 7th. And here's just a few more, rewriting them in rational exponent form. So this is going to become x to the 7/4 power. Again, whatever power is here goes up on top, and whatever your index is goes in your denominator. So that's our answer. And we got the cube root of 2xy to the 5th power. And again, we're going to put this in rational exponent form, fractional power form. So this will become 2xy to the 5/3 power. And that's our answer. And last problem, it's a calculator one. 3 to the 1/7. The key to putting this in your calculator is whenever you have more than a single number or a single variable in your exponent, put parentheses around the exponent. So when we plug this in, we're going to want to put parentheses around the 1/7. And we're rounded 2 decimal places. So we'll come over here, we'll do 3 caret, beginning parentheses, 1 divided by 7. You can put a closing parentheses if you want. TA3, TA4 doesn't need closing parentheses at the very end. And then enter. And we get 1.17. And that's our answer. And the end of that lesson. So let me go ahead and save that.